So this method for solving a system of equations where you either add the equations together, and although we haven't seen an example of this, you can get the same experience by subtracting the equations, assuming that by adding or subtracting, you eliminate one of the variables. So this method is called elimination, because in order to solve the system, we have eliminated one of the variables. That's the key. So solve each system using the elimination method. Check your work using Desmos. In other words, graph it to check it. Graph everything to check it. Hint, start by adding or subtracting the equations together. All right, so let's look at this first one. I want you to ask yourself, would adding or subtracting these equations together help us to solve this system? Okay, ask yourself that. And in order to figure out why that would be true, look at the x's. Remember, this is like a 1x and this is like a 1y right here. Look at the x's or y's and decide if I do that adding or subtracting like I did on the previous page, will something get eliminated? And I'm hoping you notice in this first one that by adding these equations together, the x's won't get eliminated, but the y's will, because 1y plus negative 1y is 0. And whatever we decide, we have to go all the way across and do that for each set. So 2x plus 1x is 3x. 1y plus negative 1y is 0. 4 plus 11 is 15. All right, so what we really have here when we do the adding of the equations together is we have 3x plus 0 equals 15. In other words, 3x equals 15. And now it's just a quick undoing that multiplication. 3 times what equals 15? By dividing by 3. 3 times 5. X is equal to 5 is equal to 15. Now remember, that's not our entire solution. That's the x value of our solution. So now we still need to get the y. And so look at the two original equations and decide, would one of them be easier to use to solve for the y? I'm just going to make the equations a little bit more clear here. You can plug the x value of 5 into either one of those two equations and it would be fine. It would work. Well, I often look at the two equations, and this one might be a debate on which one might be easier, but I always like the equations that don't have any minus signs in them if I can avoid it. So I'm going to choose that first equation, which was 2x plus y equals 4. And remember, what we're doing here is now we are going to solve for the y value, which means I plug my number that I got for x, the value of x, in for x. So that would be 2 times 5 plus y equals 4, which means that 10 plus y equals 4. And now, to undo that 10 and get y by itself, I will subtract 10 from both sides. And we get y is equal to 4 minus 10, which is negative 6. All right, so our solution should be 5 for the x and negative 6 for the y. All right, let's just check that first. And it says use Desmos, so we'll go over and we'll take those two equations and we'll put them into Desmos. Do this every single time, you guys, because you have the graphing calculator here on Desmos, and you can always know whether you've done something correctly or not in this particular part of the unit by graphing it and looking to see, do you have the intersection point? At least then you know if you've done it correctly, and you know what the solution should be, which can definitely help you if you've made a mistake. It definitely helps you because now you know kind of what it should be. So sometimes that helps you work backwards and figure out, oh, where did I go wrong here? And then even if you can't figure that out, you can write down, well, I know the solution is this. I know the solution is 5, negative 6, but I must have made an algebraic error. And you can explain that. And all of a sudden your points for like an IB score suddenly start going up, even if you got the wrong answer, because you you understand that you've got the wrong answer, but the graph is showing you what the right answer is. So you have shown also that you know how to figure out what the answer is, even if it's by graphing and not by using, say, the elimination or even the substitution method. So please always graph. All right, so notice we did get that intersection point of 5, -6. I'm going to bring that in here, just like we've done before, to show that we do have that intersection point, that we do know what that solution is. Keep wanting to do that, but I can just drag this over. Let's bring it in. And there we have it. There's our intersection of 5, -6. Let's do the same thing on the second equation here. All right. Now again, would adding or subtracting these equations eliminate one of the variables? If I did the same thing as I did before and say, okay, let's add these equations together, that gives me 16x. Remember, this is like 1y, so that'd be 12y. And that would be 44. Okay, so I get a third equation, and I know that equation is going to have the same solution as the original equations, but it really didn't help me do any elimination because I still have x and y, and I got bigger numbers, and I can't really solve for one of the variables and get a value. I can get one of the variables by itself by solving, but I can't get the value of the variables when I still have both the x and the y. All right, so what happens in this situation? Well, I do notice that these two x values have the coefficient, the number in front is 8. But since it's a positive 8x for both of them, in this case, to eliminate, I am going to subtract the two equations. Okay, so what happens then is I have 8x minus 8x, which is 0, 11y minus 1y, which is 10y, and 37 minus 7, which is 30. Okay, now look at what we've got. We have a very simple little algebraic one-step equation. 10 times what equals 30? Well, dividing both sides by 10. 10 times 3 would be equal to 30. Y is equal to 3. And then just like I did before, look back at each one of the original equations and decide, okay, which one would it be easier to plug it back into and solve for the other variable? You can do it for either one. We have all plus signs here, which is nice. I'm going to actually take the second equation. So I'm going to take 8x plus y is equal to 7. And then remember, I'm going to plug in the y value of 3. So that means 8x plus 3 is equal to 7. And now we have a two-step solving here. Let's undo the adding of 3. I'm going to try to get x by itself by taking 8x is equal to 4. 7 minus 3 is 4. And then we'll undo 8 times x. So we'll undo the multiplication by dividing both sides by 8. 4 divided by 8 is 1/2, or 0.5. So x is equal to 0.5 and y is equal to 3. Let's just check to make sure that that is correct by using Desmos. Get rid of the ones that I have in here. Let's take our equations. So 8x plus 11y equals 37. X plus y equals 7. There we have it. 0.53 is the intersection point. Bring that in to show what we have got. So that is how you solve a system of equations through the elimination method, and how you would check your answers, once again, by using a graph.